Welcome back to World of Technology. Imagine you type a simple Kubernetes command like kubectl apply, just one command. But behind the scenes, Kubernetes performs dozens of actions before your application actually starts running. So who receives your command? Who verifies your identity? Who checks whether you are allowed to perform the action? Who stores the cluster state? And who informs the rest of the Kubernetes about the changes? The answer is one component, the Kubernetes API server. In fact, if the API server stops working, Kubernetes effectively stops functioning because every important action starts here. Today, we will explore the most important communication hub inside Kubernetes and understand why the API server is often called the front door of Kubernetes. Let's begin. Let's start with the basics. The API server is the central entry point of Kubernetes. Every request made to Kubernetes eventually reaches the API server. Whether the request comes from kubectl, the scheduler, the controller manager, kubelet or any external application, everything goes through the API server. Think of it like the reception desk of a large company. Nobody directly enters every department. Everyone first talks to the reception desk. The API server plays exactly the same role inside Kubernetes. It receives requests, processes them, and coordinates communication across the cluster. That's why it's considered the heart of Kubernetes communication. Now let's understand something that surprises many beginners. When you use kubectl, you are not directly talking to pods. You are not directly talking to worker nodes, and you are not directly talking to etcd. Instead, kubectl only talks to the API server. For example, when you run kubectl apply -f deployment.yml, kubectl sends an API request to the API server. The API server then decides what needs to happen next. This design provides consistency, security, and centralized management. One very important takeaway is that kubectl is simply a client. The API server is the actual gateway into Kubernetes. Now here is where things become really interesting. The API server does not blindly accept every request. Instead, it performs several important checks. First comes authentication. The API server asks, "Who are you? Can I verify your identity?" This may happen through certificates, tokens, or other authentication modes. Next comes authorization. The API server asks, "Even if I know who are you allowed to perform this action?" For example, a developer might be allowed to view pods but not delete them. Then comes validation. The API server checks whether the request is correctly formatted. Does the YAML file contain valid fields? Are required values present? And finally, the admission controllers performs additional checks and policies. Only after passing all these stages does Kubernetes accept the request. This security pipeline is one of the reasons Kubernetes is trusted for large production environments. Once a request is approved, the API server needs somewhere to store the information. That place is etcd. etcd is Kubernetes distributed key value database. Whenever you create a pod, a deployment, a service, a secret, or almost any Kubernetes object, the API server writes the information into etcd. This is important because etcd becomes the source of truth for the entire cluster. In Kubernetes, components don't rely on memory alone. They rely on the cluster state stored inside etcd. A useful way to think about it is this: the API server is the writer, etcd is the notebook. Every important cluster decision gets recorded there. Now let's look at the bigger picture. The API server is not only used by humans, it is used by almost every major Kubernetes component. The scheduler watches the API server to learn about new pods. The controller manager watches the API server to identify differences between desired and actual state. Kubernetes communicate with the API server to receive instructions and report status. kubectl sends commands through the API server, and etcd stores data that the API server manages. An important fact many newcomers don't know: most Kubernetes components do not directly communicate with etcd. Instead, they communicate through the API server. This creates a clean, secure, and consistent architecture. That's why the API server is often called the communication hub of Kubernetes. Now let's bring everything together and watch the complete journey. Imagine you create a deployment. Step 1, you run a kubectl command. Step 2, kubectl sends the request to the API server. Step 3, the API server authenticates and authorizes the request. Step 4, the API server stores the desired state in etcd. Step 5, the scheduler notices a new pod needs to be created. Step 6, the scheduler selects a suitable worker node. Step 7, kubelet receives instructions and starts the pod. And finally, your application becomes available. Notice something important. Every major step involved the API server. Without it, the entire workflow breaks. This is why Kubernetes revolves around the API server. Let's quickly recap what all we learned today. We learned that the API server receives requests, authenticates users, authorizes actions, validates resources, stores cluster state in etcd, and coordinates communication between Kubernetes components. In simple words, the API server is the front door, the security guard, the traffic controller, and communication hub of Kubernetes, all at the same time. And here is a fascinating fact many people don't realize until much later. Almost everything you do in Kubernetes ultimately becomes an API request. Whether you are creating pods, scaling applications, or deploying services, or managing secrets, it all starts with the API server. Now that we understand the gateway into Kubernetes, our next step is understanding how Kubernetes actually remembers cluster information. That means we will dive deeper into etcd and uncover why it is called the source of truth for the entire cluster. If this video helped you understand Kubernetes better, subscribe to World of Technology and continue your Kubernetes journey with us. Thank you for watching, and I'll see you in the next video.